The removal of CO2 is crucial for achieving international climate objectives that were outlined in the Paris Agreement in 2015. Simply reducing CO2 emissions is not sufficient to reach net zero emissions. It is necessary to eliminate CO2 that has been released into the environment over the past 2 centuries of industrialization. There is groundbreaking carbon capture technology coming out of Surrey, England. Dr. Melis Daya, sorry if I'm saying your name wrong, is the lead scientist in this field. This technology has the potential to take the lead in efficiently capturing carbon dioxide and converting it into valuable products like hydrogen. How exciting is that? And it's all down to chemistry. Groundbreaking experiment technology that utilizes dual function material, DFM for short. It was tested to understand how it captures and converts carbon dioxide into environmentally friendly fuels and useful industrial chemicals. The findings of this study have been published in the Journal of Materials Chemistry. A switchable DFM developed by the Surrey team, known as NiNrNaCl, don't know if I'm saying that right, is composed of nanoparticles of biometallic alloy combined with a dispersed Na-based absorbent. These compounds work together to create a unique material capable of capturing CO2 through 3 distinct chemical reactions. This versatility makes it well suited for adapting to the ever-changing energy landscape. How exciting is this news? The lead author of this study, Dr. Melis Daya, says investing in advanced carbon capture technology goes beyond fulfilling environmental responsibilities. It presents an exceptional opportunity for the United Kingdom to emerge as a global forerunner by harnessing an immense potential of green energy products derived from this process can be used to capture CO2 in 3 important chemical reactions. The first one is converting CO2 into methane or methane, depending where you come from, a process where CO2 is converted into methane. It combines CO2 with hydrogen, H2, to produce methane, also called synthetic natural gas, and water. And the second one, a chemical process that involves converting CO2 and H2 into carbon monoxide, CO, and H2O. This reaction can be used to make sustainable synthesis gas, which is a mixture of CO and H2 that can be converted into a vast variety of chemicals using techniques that already exist within the chemical industry, moving us closer to a circular economy. And the third one, DRM, which is dry reforming of methane, a chemical process that involves the conversion of methane and CO2 into synthesis gas, taking advantage of demineralization of hydrocarbon resources such as biogas, and offering opportunities for decarbonization and CO2 recycling in the absence of green hydrogen. And this information is brought to you from Journals of Materials Chemistry. there's another system for capturing the CO2, and this is called DACS, D-A-C-S. There is a liquid one and a solid one. The liquid system draws in air to pass through a chemical solution that removes CO2 and returns it back to the air without the CO2. The solid version captures the CO2 as it goes through a chemical agent on the surface that then forms a compound. When the compound is heated, it releases the CO2 to be captured and separating it from the chemical agent, which then can be recycled. The captured CO2 then can be compressed under very high pressure and pumped via pipelines into deep geological formations. This is a permanent storage process known as sequestration, which personally, I don't like this alternative. However, they can also take the CO2 and pump it under low pressure for immediate use in a commercial process, such as carbonating drinks or cement manufacturing, which is much better. Now, there are 15 of these plants already in operation. There is some in Switzerland, Iceland, and Italy. Together, these small-scale plants capture approximately 9,000 tons of CO2 a year. Every little helps, and it's all making a difference.